Are your automation tests just a tangled, flaky mess right now? Look, we've all been there. You write a few tests, everything is green, and it honestly feels great. But then, your project scales up. You write 500 tests, and suddenly you're spending half your day tracking down false positives, waiting on super slow pipelines, and constantly updating broken selectors. It becomes incredibly frustrating, right? The code base just turns into an unmaintainable beast.
Okay, let's dive into this. As our source material rightly points out, without structure, Playwright's power is wasted. Most beginners kind of think test automation is just about writing individual scripts. But as your suite grows, if you're just throwing scripts together without a structured, intentional foundation, all that power actually works against you. Writing the code, well, that's really only half the battle. Structuring it is what actually defines your success. Welcome to this explainer. Today, we're looking at Playwright and TypeScript, and specifically focusing on the 2026 architectural blueprint for test automation. Throughout this analysis, we're going to treat test automation exactly like constructing a highly scalable building. If the foundation of a building is weak, the whole thing eventually collapses under its own weight. But if the foundation is strong, scaling up to a massive skyscraper becomes an effortless, totally predictable process.
So here's our quick roadmap for today. First, foundation, TypeScript, and structure. 2, smart locators for resilience. 3, clean code, POM, and fixtures. 4, scaling up, sharding tests, and finally 5, the debugging and AI ecosystem.
Let's kick things off right at the beginning with Part 1, Foundation, TypeScript, and Structure. So let's start right on the ground floor. If Playwright is the steel of our building, TypeScript is the concrete. Why use TypeScript instead of plain old JavaScript? Well, it gives us static typing, which means we actually catch type errors in our editor way before runtime. You get superior IntelliSense and IDE support, which vastly speeds up your coding. It enforces strong data integrity, especially when you're dealing with complex API responses. But honestly, most importantly, it allows for confident, error-free refactoring. You're not guessing if a change broke a test somewhere, the compiler literally tells you immediately.
Let's move to and see how this builds out into an industry-standard folder structure. Throwing everything into a single default folder is a massive mistake for real-world projects. Instead, professionals use a layered approach. You should have a tests directory strictly for your test logic. Then a pages directory for the page object layer. You absolutely need a utils folder for reusable helper functions like custom data generators. And finally, a fixtures folder to manage all the setup and teardown of your test environments. Separating these concerns brings just massive clarity to your code base.
Moving right along to Part 2, smart locators for resilience. With our foundation port, we need to erect load-bearing walls. Now, what's really interesting about this comparison is the stark contrast between bad legacy practices and Playwright's modern approach. On the fragile side, you have these long implementation-tied CSS or XPath chains. If a developer just wraps a button in a new div, boom, your test instantly breaks. It's incredibly brittle. But on the resilient side, Playwright champions accessibility-first user-facing locators like getByRole or explicit contracts like getByTestID. By testing how the actual user or assistive technology perceives the page, your tests become highly resilient to those underlying DOM changes.
Complementing these resilient locators is Playwright's auto-wait feature. Let me tell you, this is an absolute game changer for eliminating flakiness. There are absolutely no more manual sleep or wait for timeout commands needed in your code. Playwright automatically waits for an element to be visible, enabled, and stable before it even attempts to interact with it. This inherently boasts the stability of your whole structure without you ever having to micromanage those tricky timing conditions.
Let's step up to Part 3, Clean Code, POM, and Fixtures. Moving up to the framework level, we really need to keep our building organized as we scale up to thousands of tests. POM, or the Page Object Model, is an absolutely crucial pattern here. It actively separates your user interface logic from your test logic. So, instead of duplicating the exact same button locator across 50 different test files, you store those locators and actions in dedicated page classes. When the UI inevitably changes, you only have to update the selector in one single file, and all 50 tests are instantly fixed. It is literally the ultimate tool against code duplication. Then we have fixtures. I want you to think of fixtures as the utilities of our building. They provide the water, electricity, and HVAC exactly when and where a room needs them. Fixtures encapsulate setup and teardown logic, establishing completely isolated test environments on demand. They give a test exactly what it needs to run, and nothing else, ensuring that tests remain completely isolated and don't accidentally step on each other's toes. And this brilliantly illustrates the powerful out-of-the-box fixtures Playwright gives you to control the environment. You've got the page fixture, giving you an isolated page just for a specific test. The context fixture provides an isolated browser context. The browser fixture actually optimizes your resources by sharing browsers across tests. And the request fixture gives you a fully isolated API context for backend testing. You simply mention these in your test arguments, and Playwright magically handles all the heavy lifting of the setup. It's fantastic!
All right, moving to part 4, scaling up, sharding tests.
So your code is perfectly clean, but what happens when your pipeline takes an hour to run? Well, we install high-speed elevators. Sharding divides your heavy workload evenly across multiple continuous integration jobs. Notice how each of the 4 shards here handles 25% of the suite simultaneously on totally different machines. Setting this up can drastically cut your total pipeline execution time by, like, 60 to 70%.
So the crucial point is how exactly you configure this parallelization. If you don't enable the fully parallel true setting in your Playwright config, Playwright defaults to splitting your shards at the file level. And if you happen to have one massive test file and several tiny ones, your shards will be severely unbalanced, which completely bottlenecks your entire pipeline. By enabling fully parallel, Playwright splits the workload down at the individual test level, ensuring your shards are perfectly balanced and you get maximum speed.
Of course, even with perfect scaling, tests are occasionally going to fail in CI. That's just reality. And that's exactly where the trace viewer comes in. By configuring Playwright to capture traces, ideally using the on first retry setting so you don't accidentally slow down your successful runs, you get a GUI tool that essentially gives you X-ray vision. It provides a full timeline, DOM snapshots, network logs, and screenshots for every single action. You never have to guess what went wrong again. You can literally visually step through the exact failure.
And finally, part 5, debugging and the AI ecosystem. Let's take the elevator all the way up to the penthouse now, the absolute cutting edge of 2026 automation. The sheer volume of AI innovation happening right now is just staggering. With the release of Playwright version 1.56, we saw the introduction of dedicated AI test agents that actively help you build and maintain your framework. You have the planner agent, which explores your application and autonomously produces test plans. Then, the generator agent takes those plans and automatically writes the TypeScript files for you. And incredibly, the healer agent can run your suite and actually automatically repair tests that fail due to minor UI changes. It is mind-blowing. As we integrate these AI agents, it's really vital to understand how they interact with the browser, so you can future-proof your setup. We essentially have 2 main approaches now. The Model Context Protocol, or MCP, is ideal for persistent browser control and long-running autonomous workflows, feeding structured accessibility trees right to the AI. On the other hand, the new Playwright CLI offers these token-efficient shell commands. This is absolutely perfect for coding agents like Claude Code or GitHub Copilot that just need quick, concise browser interactions while they're editing your code. So we've built the foundation, we've erected the resilient walls, installed the high-speed scaling, and taken a look at the AI-powered future. So I will leave you with this provocative challenge. Is your test framework truly ready for the AI era? Don't let your automation suite remain a tangled, flaky mess. Take these architectural blueprints, tear down that fragile legacy code, and start building a structured, scalable masterpiece today. Thanks so much for joining me on this explainer.